Okay, a very good morning to all the assessors. I am Nakasa, Zarabi, and Dr. Izzy. I'm Nicky, and today we will talk about the conceptual design for SMK Puncak. So, as for introduction, we have divided into three parts. First, we have to see the domain-specific knowledge. Means for this conceptual design, we have to use domain-specific knowledge. Means like we have for structural part, earthwork part, water reticulation part, road system, parking. So each field requires specific knowledge for our design, as well as for the conceptual. The second is the experience knowledge in the form of best practice or of using previous design. Means what we learned before is a capstone, like Prof. Wan always say, is a capstone. We use all the knowledge we learned previously, as well as in our LI, the industrial training, combined together for this project. And lastly, specific user behavior knowledge means this is a school project, SMK Puncak. So their architecture, they have the client, so their requirement and their request we cannot sacrifice. Means we need to have knowledge, experience, and as well as we didn't sacrifice the client requirement. So this is the requirement for this project. Okay, this is the layout plan for our project. This is the whole layout plan. This is the main academic block. This is the multi-purpose hall. This is the parking, canteen, the lab, and then it's the football court, tennis court, and the recreation court. As for this project, we have or explode this project because since UKM we have a football court with a tennis court, so we need this part. So we share the facility with the UKM. We only focus on this part. It's the main academic block, multi-purpose hall, lab, and the canteen. Okay. So the objective of our project is first to transfer the building from a layout plan onto a site at a reserve forest in UKM. Means we have to transfer this project into the UKM area. Secondly, we have to use sustainable concept in the design and planning stage. Means we have to design the project with sustainable concept. Third, we have to work as a team. As I said before, we have structure, we have drainage, so all we have to work together to complete this project. This is the objective. So this is the scope of work. We have divided into earthwork, structural design, drainage, sewerage, water supply, parking, and roadway system. This is the seventh part, and I will talk about the earthwork. This is the work distribution. I will talk about the selection of site, earthwork, slope protection, and the retaining wall, while my friend Kimi will talk about the road network, parking system, and the structural. Imran will talk about drainage, and lastly, Imana will talk about the sewerage and water supply. As we are requested by Prof. OJ, structural students have to deal with structural part, environment students have to deal with environment part. So we divided into structural and environment for this project. For the site location, before we choose the site location, we need to have some parameter or some criteria in our how we choose. So we have fixed into sustainable, balance site and field, and accessibility. Means the site we choose must fulfill these three criteria. So good. First, since the contour map of UKM, basically UKM and Loop 1 and Loop 2 has been did in the last semester. I converted into a table. Okay. Since Loop 1 is very crowded and full with residential area, while Loop 2 is is wider and has more offices, like as you can see, Loop 1 has Chancellery, KKM, KRK. Those are residential, have many students, so it's not very good to have construction there because many students, if you have pollution, if you endanger the student because there are many accidents over there also. So as for Loop 2, we have less residents and the construction can carry until the night also because with many offices here like here, so even construction at night it won't disturb many things. So we eliminate Loop 1 and we choose Loop 2 as our site of selection. Okay, this is the first stage. And then secondly, for Loop 2, we have proposed two sites. One is here, this is the food court, this is the FKB new building, it's just beside the food court, this is the existing road, this one. For for this one, this is the new library, it's just the road just opposite the new library. So we propose two sides, and the reason is for the first side, this is the moon court. The level is quite flat. You can see around 28.96. So we have, you remember the three parameters, balance, cut and fill, the first one. So here we will do less earthwork. We will save a lot of cost if we choose here. But the problem is, here is the area of here is very low compared to the existing road. The area is about 50.29. So it's like slope down. So in terms of accessibility, this area is very good because if you want to design the drainage, the sewage to have a gradient, it's better to have to flow from higher ground to lower ground. So it's like if here we have to flow from lower ground to higher ground. So this side, although is less earthwork to be done, but the accessibility is not very good. So we proceed to side B. So here is a bit higher, about 39, and the road is also around 50. So this is a better side because same, the parameter is balance, cut and fill, accessibility and sustainable. And we'll talk about sustainability later. Okay, for earthwork, so we proceed to earthwork. There are many codes, so we use BS 6031 for our codes of practice of earthwork to calculate the earthwork and the balancing of cut and fill. And then we have to determine the platform level. The platform level is based on the existing level. Okay, this is the proposed platform level, this is the preliminary platform level. So as we can see, this is the road, this is the existing road, about 50, so we have proposed around this road, this is the main road. The blue color is the road around it, you can take the hall, take the academic block, laboratory and canteen. As you can see, we have different levels of platform. Okay, it will be clearer later on. This is the cut and fill. This is the, for example, this is the existing control, existing land use, and this is the proposed platform level. So for this area we have to cut, and this area we have to fill. This is the basic concept of cut and fill based on PS. Okay, so we have choose two methods. First is the cross-section method. Cross-section method we use to cover the slope. For example, we have extract the contour line from UKM, it's like this. So this is the platform level we need to. So all these areas have to be cut, for example. You see they are around here. So this is the platform level, this is the existing level, this is the distance between the line. Secondly is the grid method. For our main block, we use the grid method. And for the slope area, for the slope around here and the retaining wall, we use cross-section method. So we have exposure to two methods. Instead of like cross-section, they ask us to choose one of them, we use two instead. So for grid method, we have divided into many grid lines. Each box is 10 meter times 10 meter to increase the accuracy. So as we are advised from other consultants, also they're using 10 meter over 10 meter for a huge project like this. So after each coordinate is extracted from the contour map. The point is point A, point B1, point C1, point B1, and then we have converted into a table. These are all the existing level, means original level of UKM. As you can see like this. After that, we average it like this one, A1 plus A2 plus B1 plus B2, average it and become a box. For example, this area has to cut, so we just minus this. For example, this has to fill, and we will plus it. So we have, I have common, this is the converted box. Like this area is 51, 50 means the average of the four coordinates. So for example, I have converted. After that, we use this existing level minus the platform level. So we can see the cut and fill. For example, you can see this area all have to be cut, and this area all have to be filled. So it's quite clear that around half have to be cut and half to be filled. And I've used a clearer picture, as you can see, it's the boundary of our site. Actually, we don't have a boundary also because all the land UKM is ours, we are freely to use, but I try to fix the simple boundary for this. This area has to be cut, and this area has to be filled. So it compromise our parameter, balance cut and fill, and then it's quite easy to access because it's quite near to the main road, and it's quite sustainable because the ground is quite flat also. It's quite good for long-term usage. After that, we have to do the compaction process, use heavy machinery to compress the soil to make it safer. After that, we proceed into slope protection. We have divided into two: slope surface protection and slope protection structure. So this, we have to do a site survey as we are required in CO2. Okay, so we have site investigation. In UKM, mostly we are using what we call turfic method or vegetation slope protection. This for aesthetic purpose and also quite sustainable. See, vegetation slope it can somehow maintain itself. This is the geowet system. If the budget is allowed, we can use geowet system for our project also, because as we visit in Tasik Chini, it's quite sustainable because after we put the geowet, we can have greenery here. So it can stable the slope as well as we can make sure the aesthetic view in UKM is still green. Like FKB is quite dangerous because the land is start to settle already. So we have to focus in the matter of safety. According to JKR code, according to JKR code, the minimum factor of safety is 1.5. This is the JKR code, and the maximum berm is this 6. The berm is this. If, for example, if you want to design a field, it's 1 vertical to 2 horizontal, means 1 meter here, minimum 1 meter here to 2 meter here. It's better we have 1 meter here or 3-4 meter here, it also can. This is the minimum requirement for field area. For cut area is 1 to 1.75. Means like 1 meter here, 1.75 meter here. But it's better we use longer here because it's safer. This is the minimum requirement of JKR. And then berm is this one, means every slope we have a berm, and every slope we have a berm. Maximum we can use is 6 berm. And in order to cover the factor of safety, we use method of slice because this is the capstone project. What we learned, what I remember is the method of slice teach by Nicky Wai-Lun Ng. So we divided into each section of the slope, and then we apply this formula, and then we can get the factor of safety. It will be exceeds 1.5 because JKR requires us to be exceed 1.5. After that, we have erosion and sedimentation control plan, ESCP. So basically, this plan is to control the pollutants from exiting the site. That means they don't want the pollutants to exit the site. For example, the best management practice plan for environmental activity, site inspection. So as you can see, in order to achieve this, we have designed 2 things. One is the wash chute. Means before the tractor, the crane lift, the heavy machinery lift the site, they have to wash chute. They have to wash the vehicle, wash the tire before they connect to the main road. And it's the seal trap. The seal trap is basically we have a temporary earth drain around around the site, and the earth drain will connect to the seal trap before it discharges into the drainage. So it will reduce the pollutant. Caused by the site. And then this is a bump from basically we can see in front of the site there's a bump, right? So it's to slow down the vehicle. This also increase the factor of safety for our site because since there are many heavy machinery to pass through this area. Okay, in a short summary, so for earthwork we have 3 things: platform level, cut and fill, and slope. First we have to determine the platform level. So we are based on contour, and we determine the platform level based on resources. We try to save as much as resources we can. That means the less use of machine, less use of labor, easy accessibility, all are under this one. Cut and fill, same concept as the platform level. We try to balance it to save cost. And the slope also is best to be economical. We try to avoid the use of retaining wall since retaining wall is very expensive. And the aesthetic view, like greenery, is quite aesthetic view. And lastly is the factor of safety, because this is the most important factor in our project because we are focused on sustainability. So basically, these are the 3 things in the earthwork. Any questions? If not, I will pass it to my friend talk about the road.
tertentu.